Welcome to qnawire.
So we have an object falling freely, and in the diagram it's just a ball dropped. And so we can model this motion by a kinematic equation by saying delta y is our initial velocity times t plus 1/2 at squared. And now v0 is 0 because we're dropping from rest, and a is minus g. We're assuming we're on Earth. And we want to show something interesting, that the distance traveled every second is increasing by odd integers. Now, this seems a little weird, maybe not intuitive, but let's see what we get when we analyze this. So delta y, like I said, v0 is 0. So we get minus 1/2 g t squared, and delta y is just y of t minus our initial position. And our initial position we'll just call 0 to make it easier. So we get y of t equals minus 1/2 gt squared. Now we just want to know the distance traveled, not necessarily the displacement. And when the ball is falling, it's going down, which is what's making this negative. So I'm just going to call it positive because we just, like I said, we just care about the distance, not the total displacement. So I'll say y of t is 1/2 gt squared. And now we have position as a function of time. So why don't I just plug in time in successive or every second and see what we get out of that. So y of 1 is 1/2 g times 1 squared, which is just 1/2 g. And to make it easier, I'm going to call this k, and k is the distance it travels in the first second. And if we plug in 2, we get 1/2 g times 2 squared, which equals, let's see, this is 4. I'm going to keep it as 4/2 g because we can see this is 4k. I'll do one more. Y of 3. We get 3 squared, which is 9/2 g, which is 9k. Now, if we want to find the distance for every second, we can just subtract. So y of 2 minus y of 1 is 4k minus k is 3k. And I guess we can also say y of 1 minus y of 0 is k, because y of 0 is 0. And for the last one, y of 3 minus y of 2 is 9k minus 4k is 5k. So we can kind of see the pattern coming out here. We have 1k, 3k, 5k. Now it looks like it's going to be odd integers, but if we want to prove it explicitly, we can do this for any yn. It's going to be k times n squared. And y of n plus 1, the next second, is k times n plus 1 squared. And the distance traveled between y of n plus 1 and y of n is k times n plus 1 squared minus k times n squared. And so if we expand this, we get k times n squared plus 2n plus 1. and this is n squared. And now we can factor a k. So we have k times n squared plus 2n plus 1 minus n squared. And this comes out to k times 2n plus 1. So for every second we increase, we get 2n plus 1k. And if you're familiar with this, 2n plus 1 is how we represent an odd integer, because for any integer input, you get 2n, which makes it automatically even, and then plus 1 makes it odd. So let's check. If we have y of 0, we get k times 2 times 0 plus 1, which is 1k. Y of 1, again, this is the same thing we were doing on the first part, except now we just have an odd integer instead of a square. This is going to be 3k. The next one is 5k. You can check, keep going, and you'll see that for every increase in a second, the distance traveled is increasing in successive odd integers. And this is because of the square relationship between distance and time when we have constant acceleration in free fall.